if you find that your cells are too wide, I mean, Excel does make the cells awfully wide, sort of like this or something. If you want to make them narrower, because we're mostly working with integers here, almost all the time, except for with some exceptions, you can narrow these down by simply clicking on the upper left corner cell. It's not really a cell, but it automatically selects the whole spreadsheet. And you move the mouse over to a borderline on one of the headers, narrow the header width, and you can see that you just narrow it to something that you like, and notice that everything just snaps back to the same width. Okay, so now I'm going to show you some things about number patterns in Excel. And if I enter numbers like 3 and, I wasn't intending to do 4, but 3 and 6, and then I highlight, Excel will see that as a number pattern that you're counting in threes, and it will try to discern some kind of pattern. Now, if you do something like this, I'm not at all sure if it will discern a number pattern, although we could see if it does. And it does. It looks like it seems to be adding 4. In other words, the difference between 3 and 7 every time I update the cell. Is I'm going to do some mathematical operations on columns A and B. First of all, let's add columns A and B. Now, whenever you do that, you have to do things like enter a formula. So the addition of numbers that exist in cells such as here, and if I want to highlight that whole column, I can do this. And to put the results here, require a formula. So I will enter equals A1, and notice that A1, which is the value 3, highlights, okay, with a little blue box. And I want to add that to B1. And it has a little green box around its 3, and 3 plus 3 is 6. So far so good. Now, what Microsoft Excel will do with such things, if I have a formula, it will see that, okay, A1 and B1 are taken to be what are called relative cell references. That means that if I copy this formula, say using Control-C, Control-V, which is the Microsoft cut and paste, notice it adds 6 plus 7 to make 13. And is that the formula that it's using? Well, A2 plus B2. Okay. And if I now do Control-C to copy, and by the way, notice the rather amusing rotating dashes around the box. They're known as marching ants, by the way. Anyway, 9 and 11 make 20, and that's A3 plus B3 goes in cell C3. By the way, if you want to get rid of the marching ants, you don't need to call the exterminator. Just hit the escape key, and that'll get rid of them. And just to make sure that we got the formula, notice A3 plus B3 is in fact the underlying formula, and the result is the result that's visible when you hit the enter button. Well, you can, for that matter, you don't need to do cut and paste every single time. You can also take this little square on the bottom right corner and click on the plus sign and drag that little square down for all 14 cells, and these are all the consecutive additions of numbers on the corresponding row. So A12 plus B12 gives us the result in C12. So when we add 36 and 47, we get 83. Okay, so that's fine. What about multiplication? Multiplication is something like A1 times B1. And if I do that, I get 3 times 3, which is 9. And I can now take that, just like I did for column C, drag that all the way down with my mouse, and let go. And some of the numbers end up being these kind of funny characters because the numbers are too big to display in a column that is so narrow. So what we do is we widen the column a little bit, and there we go. We now have the ability to show 4 digits in a column. And all right, so now that's multiplication. And notice that, in fact, if I double-click on any of the cells, the underlying formula is what we would expect. A10 times B10 goes into D10, and that's 30 times 39, making 1170. E, okay, let's do something with column E. How about division? So if I do, say, A1 divided by, by the way, if I do A1 divided by B1, and notice I do not have an equal sign in front, if I hit enter, nothing happens. I just get the literal thing that I typed. So if I even said something like, hello, mom, that's not a nice way to spell mom. Hello, mom will actually be literally hello, mom. It will be literally the text that you type. So if you do something like that, if you do, say, A3 divided by B3, you'll get nothing. You need an equal sign in front to start your formula. So A1 divided by B1, okay, with an equal sign in front will give you a calculation. And notice, you've done the right thing when the cell references you typed in are in color, and those colors match these over here. And I hit enter, 3 divided by 3, gee, I wonder what that's going to be. It's 1, and I can copy that formula down, and I get a lot of different numbers. And if I expand this, notice these really are different. How about exponents? So, and I'll just expand this just a little bit because exponents tend to be a little bit tend to generate rather large numbers. So if I take A1 and I square it, I can do this, A1 times A1. I can certainly do that and square it. But what if I wanted a better way to do it? Like, for example, I wanted to do it in a way that the same formula could be used, or a similar formula could be used for cubes, or raising a number to the power 4 or to the power 5 or something like that. So squared is like, it's like this. I'll do that again. Shift 6 on the keyboard. Okay, Shift 6. And that gives you this little caret symbol, a hat symbol. And I'm going to enter a 2. And 3 squared is 9. Now, I'm only doing this operation on the numbers of column A. So only A1 got the operation. And if I now do this all the way down, I can get some fairly big numbers going into the thousands. And so that's 6 squared, 9, oops, I don't know why I keep doing that, 9 squared, 15 squared, and so on. We could just keep going all the way down to 42 squared. Okay, those are squares. Of course, cubes, you would simply just do the same thing again and replace it with the number 3. Instead of a 2, you just put a 3 after the caret and hit enter, and 3 cubed is 27. Now, notice what happens. I'm going to replace all of those squares with cubes. Now watch how I can do this. It's as simple as taking that lower left little square and dragging it down, and it clobbers all the values and replaces them with the cubes. So down on the bottom we get 42 cubed. That's 74,088. And anyway, so that's cubes. How about square roots? Now, square roots may not work out to round numbers. So let's say that I took the square root of the numbers in column F, and they may not work out nicely. So the way to do that, there's 2 ways of doing it. You can do equal sign F1 to the power of, in brackets, 1 over 2. that will give you the number raised to the power 1/2, which is indeed a square root. You can also go with a Visual Basic function built in to the Excel spreadsheet, and that's =SQRT, and then enter the cell reference F1, and you get the same number. So the only disadvantage of SQRT is that there is no corresponding cube root function or fourth root function or anything like that. Some cubes are perfect squares. In the case of 9 cubed, it's also you can also take the square root. Also 36 cubed. So it looks like wherever we ran into a situation where there was a perfect square in column A, we got a whole number square root in column G. Where that was not the case, it looked like column G ends up being some. And I'm going to start doing some dice rolls. So first of all, they go by this random number generator, which is just the function rand, and all this rand does is return a number. Okay, and well, it returns a different number every time it's run. In fact, I can actually do a whole bunch of these, and it's a whole bunch of different random numbers. In fact, I can widen this column and show you that these numbers go on at considerable length. So notice by making the columns narrow, we hide a lot of details here. At any rate, so if I drag that box over sideways, I got a whole bunch of random numbers. But these random numbers aren't very useful. What we really want to do is use these random numbers for a purpose. Because that's what, if you want to simulate a game of chance or something like that, you might be interested in this. Well, we have to have a way of truncating or cutting off the decimal that we randomly generate using the random number. Now let's say we're doing a dice roll. So I need 6 random numbers. Now rand produces numbers from 0 to 0.99999. It doesn't quite go to 1. So if I do trunc rand, I might get a 0 or I might get a 1, but in fact I'm afraid I may always get a 0, and that's because this random generator never goes to 1. It never quite goes to 1. So if I keep chopping off the decimal, all I get is the integer in front of it. Well, that's not very helpful. So let's modify this. Maybe inside the bracket I want to multiply it by 6. And that's like 6 sides of a die. So if I get, say, 1/6 times 6, I get 1. If I get, 5 over 6 times 6, I get a 5. So I just rolled a 1. Let's see if anything happens. Oh, look, how strange. I just rolled a 0. Well, that isn't supposed to happen. And do I ever roll a 6? Let's try it for a whole bunch of rolls. Let's just go over here. I don't seem, looking at this, it don't seem to ever get a 6, but I get a lot of zeros here. Well, that's not quite what I wanted. Now, I'm getting numbers, in other words, from 0 to 5. I want numbers from 1 to 6. So to increase my range, after that whole function is typed out, I just add 1. And that moves, it shifts the range of the function 1 more into the positive direction. So now instead of getting the numbers from 0 to 5, I will now get the numbers from 1 to 6. And there I rolled a 3. Let's see if a 0 ever occurs again. And let's go to 10. We don't get zeros, but we certainly get a 6. And going this way, lots of 6s, no zeros. I think we did it. I think this is our dice roll. And that's an example of a dice roll simulation done using a random number generator. But of course you can do lots of things with it. You don't need to just simulate dice rolls. You can simulate a lot of random processes using things like this. What I want to do, if I wanted to produce the numbers between, say, 1 and 24, well, I can multiply my rand by 24 and make sure I add a 1 to ensure that I don't go from 0 to 23. But what if I wanted from, say, 2 to 25? Oops. Sorry. What if I wanted to go from 2 to 25? Well, I can just add a 2 here. And if I think about that, that's the lowest I can have is a 2. And the highest I can have, I don't quite go to, well, maybe I do go to 24. Let's see what happens here. Let's see if in a whole bunch of these dice rolls, do I ever get a 24. Now that might be chancy. Maybe I never get one, but that's not the fault of the... There, we got a 20. Yes, we got a 25. By adding 2, I've increased the entire range by 1. That means I increased both the lower end and the upper end of the range by 1. So yes, I will hit 25. There we go. And here's another 25. And at any rate, I'm done.